Hello, I'm Sourav Basu, and what I'm going to present is the application of critical chain in large capex and construction projects. The reasons why it is still not a mainstream solution, how we can possibly bridge that gap, and what sort of results can be achieved if we are able to bridge that gap. Now, to state the obvious, it is quite well known that all over the world, construction projects or large capex projects are delayed. They have significant time and cost overruns. And it is also well known that when time and cost overruns happens, it does not only affect the owners, but it affects all the stakeholders who are there in the system. The engineering consultants, the contractors, the equipment suppliers, and the subcontractors all suffer through severe working capital issues. And therefore, it is quite obvious that if we can accelerate infrastructure projects, then the business potential or the business benefits are quite significant. And it is also well known that there are certain challenges which exist with respect to accelerating these projects. There are lots of limitations of cash, limitations of how much workforce can be mobilized, limitations of trained managers. It is also well known that Murphy is ever present. There are hundreds of reasons why work gets delayed at site on a day-to-day basis. And in infrastructure or capex projects, another big factor is that there are a lot of external stakeholders. A lot of organizations come together for the purpose of one project, and each of them have their own business interests. So it's a big challenge aligning them to a common goal. Now, in mainstream project management, the obvious response to these challenges is to be able to do or able to improve everything at the same time. So the basic modus operandi is to be able to monitor and control everything. Now, in recent times, with the way information technology and the speed of the internet has improved in leaps and bounds, there is a mad rush to go for more real-time solutions in terms of real-time data tracking, in terms of real-time alerts, in terms of real-time report generation, etc. The basic assumption is that the reason why we are not able to accelerate projects is because we are not getting to know about the delays as soon as they happen. So in any moderately large capex project, on a weekly basis, there are hundreds of places where delays happen. So the assumption is if managers get to know about the delays as soon as they happen, then the outcome would be significantly different. And this effort has been going on for the last 10 years. And we are yet to see any significant improvement in timeline or cost performances of these projects. And the reasons are obvious. All the requirements of being able to monitor and control everything are about adding more managers, doing more frequent planning, analyzing more and more data, and that effectively stretches the already limited capacities even more. On the other hand, critical chain has been existing for the last 30 years. It's a simple concept around focusing on less amount of work and doing them faster, which is basically a solution for an imperfect world, a world which is full of scarcities and full of uncertainties. This solution has been existing for a very long time, and we know that if this is applied, then the obvious benefits would resolve most of the challenges that we are seeing today in capex projects. However, when it comes to implementing critical chain, there is a pretty standardized solution for new product development or engineer to order type of projects. However, the world of capex projects is not exactly the same, and it seems that the standard solution is incompatible with the world of capex projects. And what we feel, there are three primary reasons why that happens. Critical chain as a concept, it depends on identifying the constraint and staggering the work around the constraint. Now, and these constraints are mainly about the resource limitations an organization has. Now, in terms if we think in terms of Capex projects, the very assumption of resource availability itself is a big uncertainty. You never know what will be the workforce or what will be the managerial capacity or what will be the exact flow of funds that you will get when the project is in execution. So this becomes the first roadblock. Secondly, the organization that delivers a Capex project is a transient organization. It comes together from different parts of the organization for the duration of the project, which might be 1.5, 2 or 3 years, whatever be the duration of the project. They come together for that period and then they get disbanded. Also, there are a lot of external stakeholders in the system, the contractors, the suppliers, who also come together for this period of time. All of them do not even come together at the same time. They come in at different points in time and exit the system at different points in time. And on top of that, these projects these are one-time exercises, and there is also a lot of pressure of responding to that timeline. Now, in the middle of all this, it is very difficult to educate the entire organization structure to follow rules or follow ways of managing projects which are counterintuitive to the way they are used to working. And the third reason is that there is an existing ecosystem of project management in these type of projects. At the highest level, the business milestones and the key business targets are set. Based on that, there's the PMO, which creates a sort of an integrated schedule with internal and external stakeholders. Below that, there are the silo schedules that the contractors and the vendors who come in, they submit. And at the lowest level, there is also the requirement of collecting progress data, like cubic meter of concreting done, or the amount of fabrication done, or the number of drawings submitted. These go either into billing or into understanding the project at a more aggregate level. Now, the obvious question that comes up with so many schedules and systems running in layers across the organizational structure, where do we apply critical chain? If we apply critical chain at the top and leave the stakeholders out of that implementation, then there is very little chance of success if they are not following the principles that are set on top. On the other hand, if we go and do piecemeal implementations at the vendor and contractor levels, and even if we can get local improvements, whether it is going to translate into overall improvement of project performance. So there is a confusion as to how to apply critical chain in this ecosystem. Given the challenges, what we'll try to do now is we'll do a small thought experiment to try and understand how these gaps could be bridged. In this thought experiment, I'm going to use the simple picture to explain the execution of a small work package. The blue tasks that you see in the towards the beginning are the detailed engineering tasks. There are 5 of them, and they're 1 week each. Each requires 3 engineering resources. Once all these engineering drawings are released, there are 7 weeks of civil works, which is denoted by this golden task. And similar to engineering, there are 3 resources of civil who are required in order to get this done in the given amount of time. And finally, when the entire work front of civil is handed over, installation and commissioning of an equipment can happen, and it also requires 3 resources to get it done in 4 weeks. In total, there are 16 tasks, and the duration, for the sake of simplicity, is 1 week for each task, and the total amount of time that is required to commission the work package is 16 weeks. Now, let us first look at the capacity limitation problem. Now, let's say we start with this assumption in planning, but when we get into execution, what happens is this, that instead of 1 work package, we end up with 3 work packages, and the amount of resources available, instead of 9, it is just 1/3. So one way of looking at this problem is to try and solve it the way mainstream project management works, which is about following dates. So since the start dates of all of them are today, we need to start the work. And if we need to do the work in a start as soon as possible mode, then the right thing would be to distribute the resources and try and ensure that all the work is started today. So this is what happens when we do that. when we distribute the resources and we start as soon as possible, because now there are less resources for doing each piece of work. It just, instead of 1 week, it now starts taking 3 weeks. And the overall time, it's just pure arithmetic. It is 48 weeks. If you think of each work package as a flow of work, what is essentially happening is this strategy is slowing down the flow of each of the work packages. And on top of it, if you now look at the individual tasks in the system, in addition to the resource limitation, if now Murphy strikes at different places, wherever it strikes, it's going to add to the delay directly. Now, let us look at this from the perspective of staggering of work as in critical chain. So instead of spreading the resources, if we kept the resources concentrated on one task and only then allowed the next task to start, what would have happened is this. So here, as you can see, the individual task durations do not expand, but the fact that the resources are moving from one task to another due to the stagger, it is doing a similar thing to the flow. So in this case, it is not slowing down the flow of work in terms of the speed of each and every task, but it is doing the same thing. It's slowing down the flow of every work package by bringing in a lot of disruptions in between. And in this case also, on top of the resource limitation, if Murphy strikes, wherever it strikes, it's going to add to the delay of the project. Now the final answer is a little better than the previous case because of the time saved in handover, but otherwise, essentially, it is not very different to the other way of working that we saw before. So we'll now try to attempt a third way of looking at the same problem. What will change is, instead of looking at the detailed network, we are now going to look at a network of some strategic batches. So here the batching is pretty self-evident. All that we have done is we have taken the detailed activities or the tasks of the similar resource type and batched them together. And there can be other ways of batching as well. This is in terms of the direct resources. We can also do batching in terms of the managerial resources, as we typically do in procurement type of tasks, though it is mainly the job of the purchase department. But during the course of technical and commercial negotiations, the operational people and the top management comes in together. So we can think of batching procurement tasks in terms of the requirement of managerial resources. There can be also batching of collaborative type of work. For example, towards the end, especially during the installation commissioning phase of any equipment, there are electrical, instrumentation, and mechanical people who need to come and work in close collaboration with each other. So we call them collaborative batches. So there can be different ways of batching the work in such a network. In this case, we are taking a very simple example. We are saying the strategic batching is only in terms of the type of resources being used. So there is nothing that has changed in the network. It's only that instead of it being a detailed network of tasks, it is now a network of super task or focus and finish batches. And we are calling it focus and finish because the simple rule for this network is that whichever super task we take up, we need to concentrate all our resources on it, put our best effort to get it done in the shortest possible time. So basically focus and finish each batch as they appear. Now, if we just follow the simple rule, then what emerges is something like this. Now, if we do this, the major difference which is coming with the previous cases is obviously the outcome is way better. But what we have essentially done differently is for each work package, we have tried to maintain the maximum speed in the flow of work. The way work flows from engineering to civil to installation commissioning, for every work package, the speed of the flow is what we have maintained. And basically the work packages have gotten staggered by the civil task that we can see is of the longest duration. That is the outcome of the network. But essentially in the way we are working, it is just about maintaining the speed of the flow of every work package. So we are not starting work package 2 early. We're not starting work package 3 early. We are starting work package 1 first and we are ensuring it goes through at the fastest possible pace. And once the resource becomes available, we're applying the same logic to work package 2 and 3. Also, if you now look at the network, unlike the previous cases, not everything in this network is critical. Delays or Murphy striking in the blues and the pink tasks are not going to cause delays to my project immediately. By doing this, we have naturally followed the low work in progress rule that critical chain suggests. In addition, if we modify the network a little bit, we can see that there is now time buffers which are available, and therefore the buffering rule also becomes automatically applicable naturally in this way of working. So this basically addresses the first problem of not being able to predict the availability of resources once we get into execution. So the rule is simple. If we need to look at the network, not as a detailed network, but as a network of focus and finish batches of work, and whenever we face resource constraints, the simple rule is to prioritize the batches and drive focus and finish by concentrating all the available resources on one batch at a time. So if we have less amount of resources, we try to load the resources on the first priority batch. If there is anything balanced, we put it on the second priority batch. If there is nothing balanced, then we let the third priority batch wait. But does that mean we are accepting the delays that are coming as a result of this? Because our initial target was to complete in 16 weeks. Now it's going to take 30 weeks. So of course not. The management will be looking to take actions, will be trying to mobilize more resources. But the important thing is, if you looked at the network before, it consisted of 48 tasks. This is a much simpler network of 9 tasks. So it's pretty easy to do an impact analysis and understand that if the management has to work towards getting more resources, what the impact analysis very easily tells us that that effort is best spent in trying to get the civil resources, because that is what is holding the due date of my project. So this way, the management attention can also be focused in the right direction. Now, this also gives us an idea of the third problem, which is where should critical chain be applied. It is obvious. It is basically telling us that applying critical chain at detail levels is not good for the project or the outcome of the project. The rules have to be applied, or critical chain has to be applied at a level of these focus and finish batches. So this can only be formed at a higher level of management. Now, this then raises the question that, okay, then how do we align the different stakeholders who will come in at different points in time? Those are the people who need to work on the detailed schedules. And that problem we solve by defining a 2-tier network. And the simple idea of the 2-tier network is the network runs at the tier 1 level. The tier 2 level is the basically the level of the detailed activities that are there in the local schedules of the different stakeholders. And while execution happens, the detailed schedules that are generated are always in line with the critical chain plan because they are subordinated to the network on top. They don't form a network of their own. What schedule at the lowest level will be generated is determined simply by the progress that we make on the network above. So this way, we don't need to educate everybody in the organization. What we need to do is we need to get the buy-in on top on the plan, and the focus and finish plan becomes also the mechanism, the simple mechanism to align the external stakeholders through the contract. So basically the alignment is not in terms of very detailed schedule of dates, but it's in terms of basically major milestones and the focus and finish durations. So in terms of applying this in Capex projects, we are not eliminating any of the requirements. We are in fact incorporating all the requirements of detailed scheduling and progress reporting, but it is incorporated in one single plan, which is driven by the critical chain network at the top. So now that we have been able to define a network that is able to hold all the stakeholders together, we come to the last piece of the problem, which is about having a transient organization that only comes in to do the project and goes away. From the structure itself, what is becoming evident is that we are applying all this counterintuitive rules of critical chain only at the top level. So essentially, we only need the top and senior management buy-ins. Now, the simple network is also doing something more. Basically, instead of trying to align contractors and vendors to very detailed level dates, it gives a very simple logic for contractor and vendor alignment. This is also the level where the focus and at the level of the focus and finish tasks, the priorities are getting determined, and the release control is also happening at that level. So all the rules of critical chain that we need to apply, and the monitoring and control of the constraints, etc., whatever we need to do, is now applicable to only this level. And the rest of the layers below, if we have the software which can make sure that in a multi-tiered fashion, it can translate the critical chain level network to detailed schedules below, and it is able to receive the progress tracking, the data at the progress tracking level, and is able to analyze and throw it back to the network, then it's business as usual at the lower levels. We don't need to change anything there. People can still follow their schedules that come in a prioritized fashion, driven by the critical chain level network, and they can still continue reporting the work in the normal way. And the system is able to take care of all that, of all the implications. So essentially what we are saying is applying critical chain in Capex projects is as simple as creating a focus and finish network at the highest level, and then just monitoring and control that network. A software can take care of the rest of the detailed stuff that goes on in projects. Now, what I'll try to do is I'll try to illustrate this simple mechanism through a case study. And this case study is about a shipyard project that we did. The details are there on the slide. You can go through it. But the cornerstone of this project was this 200-meter long shiplift that the organization was making indigenously for the first time in India. And for shiplift is basically a platform that stays underwater. The ship can float in, and the platform brings the ship up to the level of the ground, and it increases the capacity of any shipyard. So the other option is to have dry docks, but the problem of dry docks is if a ship is already inside the dry dock, then you cannot put another ship in. Other ships have to wait. But having a shiplift, it greatly improves the capacity of a shipyard. Now, this was the cornerstone because this company, there's this company called Syncrolift who are practically monopoly in making shiplifts. And instead of choosing them, they were trying to make the shiplift on their own for the very first time in India. And they were targeting a record cycle time for the entire project. And in case the shiplift is not ready, if there is any problem and the shiplift doesn't get commissioned, then it's impossible to get business for the shipyard, because everybody knows that you cannot launch the ship, or even for repair business, you cannot get a ship in. So if you can't do either of those, then it's impossible to get business. So this was the most risky part of the project, and also the most critical part of the project. So in my example, I'm going to focus purely on the shiplift, mostly for simplicity, and also because this one piece of the project involved multiple contractors and vendors across India, spread across different locations in India. And that's why I'm going to choose this as the case study to explain the mechanism through which critical chain was applied. So before we jump into the case study, let me quickly give you an idea of what this shiplift entailed. If you look at this picture, this is these are the two piers that are extending into the sea, as you can see. The platform is supposed to come in between the piers. At this point in time, the platform is in bits and pieces, and it was supposed to be constructed in 16 pieces, and you can see one piece getting erected here. There's going to be 15 more of those. Once the platform is put in between these piers, we also need to put 60 hoists, which are going to come here on this side, on this pier, and also on this side. Those hoists are basically the same thing as what we have in elevators. They will have ropes which will hold the platform and all 60 of them have to work together to lower the platform or to bring it up. Apart from that, there was a fourth piece. Once the platform brings up the ship, then we need to have a transfer system which is going to travel over these rails that you can see just have been started to be put on the ground. So they're going to travel over these rails and they're going to go under the ship, lift it up, and again over those rails, they're going to get the ship inside the shops where they're going to be worked upon. Or if there's a ship inside the shop, the transfer system is going to take it all over the platform, then come out, and then the platform is going to lower the ship into the water. So these were the major four pieces of the project: the civil works, which was being done by one contractor; the fabrication works, which is being done by one contractor; the hoists, which are being done in a different location by the equipment supplier; and the transfer system, which is also being supplied by another equipment supplier at another location. So when we went in and when we studied the plan, the individual local schedules that each of the stakeholders had, and we tried to put them together, it sort of looked like this at a very high level. So what this essentially means is the Shiplift civil works is going to start early and it's going to continue for a very long time. It has to go a long way into the sea. And the challenge was that in order to go into the sea, you have to put a platform that is going to stand in one place. It's going to drive three piles in front of it. Then the platform needs to move over those three piles and drive the next three. And this is how it moves. So it sort of moves at a snail's pace, and it takes very long to build a 200 meter pier like that. So if you looked at the schedule of the individual schedule of the civil contractor, they had precise dates of when a certain amount of work front on the pier is going to be available. Using those dates, the platform erection people had created their detailed schedule that the moment a certain amount of work front is available, they're going to lower one platform piece, one of the 16 platform pieces. And similarly, once the platform piece is lowered, then the hoist people can come and they can erect the hoist on top of them. So this is how the entire set of dates were there in the schedule. So basically, civil works provide a little bit of work front. Platform fabrication puts in a piece of the platform, hoist come in, put the relevant or the respective pieces of the hoist, and by that time the civil works provides the next piece of work front. So this is how the detailed schedules were created. So if you look at the plan at this level, what it basically says is that civil works is going to give a little bit of work front to the platform guys. The platform contractor is going to lower one module of the platform, and the hoist people are going to come and put four hoists on top of the platform. By that time, the civil works contractor would have given a little bit of the next work front, and platform is going to put the next platform, and so on and so forth. So it's basically a sequence of it requires a sequence of highly synchronized movement of all these different contractors in the same area. And if any of them delays, then it's going to have a cascading effect on the rest. And that is a very risky situation to be in at the time of installation of such a crucial piece. So the way we started looking at the project was by trying to figure out the focus and finish durations of each of these bars that you see in the picture. And what we mean by focus and finish duration is what is the fastest we can get each of the bars done independent of the rest of the project. So for example, in civil works, as I explained before, that civil works had to proceed in a certain way. So it was like movement at a snail's pace. What is the best that we can do? And as it turned out, that because it was a huge shipyard work that was going on and there was a port coming up nearby, there was a jackup rig which had the capability of piling from the seaside. So the limitation of having to move from land, that was broken. If we bring in the jackup rig to also do piling from the sea, then basically we can reduce the duration of the shiplet civil works drastically. When we look at platform erection, it will take this long to erect the platform because we're erecting the platform piece by piece. So if you have to erect 16 pieces one after the other, this is the time it has to take. But if there is a way of aligning the platform, all 16 pieces before we lower it, then the duration of the platform can also be drastically improved. Similarly for hoist, the reason why hoist erection is taking so long because they're waiting for the work front to be available from platform erection piece by piece, and that's why there are 60 hoists. So if they put in more people, if they get the entire work front and they can put in more people, they can get it done much faster. So once we put those assumptions in place, this is what came out. And so far, we also tried to find out the focus and finish durations for this platform fabrication, hoist manufacturing, and transfer system manufacturing as well. And they were much simpler because there was actually a lot of work, repetitive work to be done over a long period of time. The duration was limited by the number of qualified subcontractors that each of them had. Now, if we convince them to qualify a couple more subcontractors and get them on board so that we could do them faster. And this is how this focus and finish plan was created. Now, the benefit of this focus and finish plan is the work front handover and the accountability of each of the contractors is very clearly defined. If there is delay in civil works, there is no way platform erection can happen, hoist erection can happen, and there is no confusion as to who is accountable to recover the delay. So this was basically the plan, and as you can see, the fitting buffers have been exposed, and those are the things. Basically, the fitting buffers are the one which make the plan stable. So we know even if uncertainties happen, even if Murphy strikes, it is immediately not going to hurt the end date of the project. There is sufficient fitting buffer to absorb the impact of those delays. Now, so far so good, but obviously when we went into execution, things did not pan out the way we expected, and we had to react to the situation as and when they emerged. Now, just to be sure, the plan that you see here is a focus and finish plan built at a very high level. It doesn't mean that we are missing the details are below them, and it's a job of the software to basically generate the detailed schedules on a daily basis, and then based on the progress that is happening to throw the impact back on top. So what happened when we started the project was, as soon as civil work started from the land side, we found that at a depth of 30-32 meters, there was hard rock strata, and whatever rate was planned for the piling, within the first 2-3 rounds, it was evident that instead of 7 days, it was taking around 12 days to pile. So the software, once it got the progress data, it was able to analyze and throw that as a warning to us. It projected a huge delay, and by looking at that, coming up in the future, immediately actions were taken. So there was a time study done to get some local improvement. The scope of the marine piling, which was being done by the jack-up rig, it had a much more powerful piling equipment on top of it. So that scope was increased, and for the land side, improved rigs were ordered at extra cost to be mobilized so that we increase the speed. So once these actions were taken, again, the rate improved and the system analyzed the data and projected that, okay, now we have recovered the project. The second thing which happened was in the material supply for the platform. The transporter suffered a breakdown in the ship in the middle of the sea, declared bankruptcy, and the ship was stuck in the sea for over 5 months. And that immediately pushed out the project by a huge margin. And there was no way to recover this. So we had to change the strategy. Instead of erecting the platform in one piece of 16, it was decided that we are going to erect the platform in two parts of 8 each. Then the third big thing that happened was that there were a lot of material which was required for doing this platform erection. Some minor material was missed, and it was discovered very late. And by that time, we were already too late to recover, and the project has gone out. So again, the commissioning strategy was revised, and it was decided that the balance material was going to be for the last 3 pieces of the platform. So we'll go ahead and commission the platform in 13 pieces, and we would be able to mitigate all the risks that we might face for doing this the first time. and we'll be completely ready with the last 3 pieces. The moment the platform for the first 13 pieces is commissioned, we would go ahead and do the rest, and that would be that should be much more predictable. And this is how we finally ended up, in spite of all these big delays, we ended up being 4 months late in the project. Uh, by the way, just to be sure, the reasons of the delay and the actions that I'm describing are only the big things that happened in this project, the big things that really affected the timeline. If you think about the detail level below the bars, on a day-to-day level, there were lots and lots of delays that happened. But that's the advantage of having this high-level plan. A lot of those delays do not affect the bars at all. So we don't really care about the local delays as long as they don't affect the network that we have created on top. So this was the execution of the Shiplift project, and the entire project was delivered in 28 months, which is still a record. And we have applied this in many projects in India. I've shown you, I'm showing here 4 projects, of which the thermal power plant is basically a huge project, which goes on for around 4.5 years. If you look at the schedules, there would be over 100,000 activities, and the network that we create is around 800 tasks. Then comes the case study that I explained, that of the Greenfield Shipyard. Here also, it was a pretty large project, over 50,000 activities and 300 tasks, focus and finish network. The third one is our brownfield textile plant expansion. We did 2 expansions. Both had interactions with the existing operations. We did both with a very thin management team. The location at which these projects were happening had severe rainy seasons. And this is the ratio, over 20,000 activities across the schedules, and the critical chain network was only 150 tasks. And finally, a very different type of a project, which is essentially more related to real estate type of projects, was new school setup along with the playgrounds and all the other facilities. And 6 of the schools were done through the system. Each of the schools had a 70 to 80 task critical chain network. And these were the results that were achieved. These are the testimonials from the customers. So that brings us to the end of this presentation. Thank you very much for listening. And if you have more questions, you need more clarifications, you have a case to discuss, this is my email ID and my phone number. And I hope to see you during the Q&A session. Thank you.